Dear colleagues, academics, and industry representatives, welcome. We are gathered here today to place the concept of sustainability, which has unfortunately been hollowed out by populistic rhetoric, back where it belongs, on the engineering table. As you can see from the title, our topic is food recovery and redistribution engineering. Why engineering? Because food recovery is not an emotional reflex consisting of feeling sorry for a spoiled tomato. It's a complex system design where the laws of thermodynamics, microbiological risk analysis, and nonlinear logistics optimizations intertwine. As a food engineer, when I see an apple thrown in the trash, I don't just say, what a waste. I see the 70 liters of water used to produce that apple, the nitrogen drawn from the soil, the diesel fuel consumed, and most importantly, to increase in entropy in the system. Our job is to reverse this entropy. Throughout this presentation, we will proceed with a skills-focused and entirely technical perspective. We will discuss that supporting social initiatives is possible not just by placing a donation box, but by managing the cold chain, establishing data architecture, and filling legal gaps with good Samaritan laws. In our flow, we will navigate a wide spectrum from the EU Green Deal to the technical details of Turkey tax procedure law, from fields in Spain to RFID-based trash bins in South Korea. If you are ready, let's leave emotions at the door and enter to operational reality, the kitchen and laboratory of the business. Remember, good intentions alone do not kill bacteria, but a correctly implemented standard operating procedure saves lives. This course is designed not as a theoretical discussion of sustainability, but as a structured technical framework for redesigning surplus food systems. Over the coming sessions, we will treat food recovery as an integrated engineering system composed of legal infrastructure, food safety protocols, digital architecture, economic modeling, and operational logistics. You will not only understand how food moves through the supply chain, but how it can be intercepted, validated, and rerouted safely and efficiently. In short, this is a course about transforming intention into measurable, traceable, and optimized engineering operations. By the end of these courses, you will be able to evaluate food recovery system through a technical and analytical lens rather than a charitable one. You will develop the ability to design food redistribution models aligned with food safety regulations and thermodynamics constraints, integrate legal, fiscal, and economic parameters into operational decision-making, build traceable data-driven infrastructures using digital tools and standardized protocols, conduct risk assessment and validation processes within cold chain logistics, analyze international models and adapt them into scalable, locally applicable systems. More importantly, you will gain systems thinking competence, the ability to see surplus food not as waste but as a recoverable resource within a structured, optimized network. This slide presents the roadmap of our session. We will start with legal and technical foundations, move into operational process management, analyze selected case studies, and finally explore future-oriented models supported by technology. In short, we will examine how food recovery can evolve from a goodwill initiatives into a structured engineering-based system. The paradigm shift you see on this slide summarizes the evolution our sector has undergone in the last 10 years. What used to come to mind when food banking was mentioned? A warehouse, a few well-intentioned elderly volunteers, and plenty of pasta and rice nearing their expiration dates. This old model was unplanned, dataless, and could only manage dry food with near infinite shelf life. However, the SDG 12.3 target forced us out of this romantic charity mindset and into industrial system engineering. Why? Because the bulk of waste is not in pasta. It's in high-risk cold chain requiring fresh products like fruits, vegetable meat, and dairy. Taking a lettuce from the field and putting it on a needy person's table within 48 hours without breaking the cold chain is, believe me, something statistically more complex than sending a rover to Mars. Because the rover on Mars has a longer shelf life than the lettuce. In the new model, we are now talking about cold chain logistics and data-driven matching. We are talking about algorithms that match waste data from a supermarket spec of house with the daily protein needs of a soup kitchen in milliseconds. This is no longer a social responsibility project. It's a reverse logistic operation. The waste hierarchy command us, if you cannot prevent it at the source, offer it for human consumption. Energy recovery or animal feed is a consolation for failure for us engineers. The real success is ensuring that food enters human biology while retaining its value. Engineers usually don't like laws. They find them restrictive. However, in the food recovery business, laws are our boundary conditions. On this slide, you see three different legal approaches in the world to stake, carrot, and protection models. France slammed its fist on the table with Loi Garou and just the sanction model. If you are a supermarket larger than 400 square meters and are caught throwing away edible food, you pay serious fines. Italy, with a more Mediterranean approach, adopted incentive model via the Gatta law. They said, if you donate, I will reduce bureaucracy and give you a waste tax reduction. The Good Samaritan Act in the USA is a complete shield. It protects the donor from civil and criminal liability arising from donated food as long as they are good intentioned. Considering how prevalent the litigation culture in the US, without this law, no one could give even a slice of bread to anyone. What about Turkey? We are in a financial haven. 100 tax-based deduction and VAT exemption is an advantage not found in many parts of the world. When you go to companies CFO and say the cost of destroying this product is X Turkish lira, if you donate, the tax advantage you will gain is Y Turkish lira, and if Y is greater than X, that food gets rescued. Our duty is to set up this equation and present it to management. Food safety is not a nice-to-have feature, it's a necessity. Donated food is not second-class food. Its safety must be of the same standard as first-class commercial products. Here, our biggest enemy is thermodynamics. The temperature bands between 5 degrees Celsius and 60 degrees Celsius which we call the danger zone, is a disco where pathogenic bacteria like as Salmonella, Listeria grow logarithmically. In a food recovery operation, a volunteer driver carrying chicken meat in the trunk for 3 hours, saying the weather is cold, nothing will happen, is equivalent to attempt murder. Therefore, validation is mandatory. We have to use digital data loggers in vehicles and warehouses. If there is no data, the food is not safe. The most critical technical details on this slide is EU Regulation 2021/382, Freezing and Retail. For years we were taught fresh meat is not frozen at the market. However, the EU stretched the legislation to prevent food waste. Now, meat approaching is used by the it can be frozen by the retailer on the condition that it is donated. But this doesn't mean throwing the meat in the freezer. Blast freezing must be done. Ice crystals must not tear the cell membrane, and the date of freezing must be printed on the label. This technical detail is an engineering victory preventing thousands of tons of protein from going to waste. Friends, in the 21st century, you cannot rescue food you cannot measure. If food safety traceability is not just a software feature, it's the fundamental mandate of EU Law 178/2002. The rule is simple: one step back, one step forward, meaning you have to know who that yogurt came from and who it went to. Let's consider a potential crisis scenario. It was announced that there is a risk of metal fragment in a batch you donate, and if you haven't digitally recorded which charity you gave that batch to and on what day using GS1 standards, you cannot recall that product. If you cannot recall, a public health risk arises and the system collapses. This is where blockchain technology comes in. Don't think of blockchain just as Bitcoin. In food safety, it's mean immutable proof. When the market says I delivered this milk at 4 Celsius degree and records this on the blockchain, this data can no longer be manipulated. Also, thanks to API integrations, the market's stock management system must talk to the food bank software. We must eliminate the human factor. We don't have the luxury of saying, oops, I entered the expiration date wrong. Technology is the backbone of philanthropy. The most ruthless but realistic rule of environmental economics, polluter pay principle, PPP. In a capitalist order, if it's cheaper for a business to throw food in the trash than to donate it, that business will throw that food in the trash. Our duty is to change this economic equation. The concept of avoided disposal cost I mentioned in the slide is critical. The higher the gate fee paid to the municipality for every ton of waste going to the landfill, to more attractive donation becomes, meaning the state needs to make waste generation expensive. The smart beans example in South Korea showed the power of technology in changing behavior. These beans are IoT based. The citizen scans their cart while throwing trash. The lid opens, the waste is weight, and the fee based on weight is reflected directly on their bill. Pay as you throw. When we can say pay as you throw. When the system was installed, food waste decreased by 30% because when their wallets are touched, people learn to squeeze the juice out of the that banana peel before throwing it away. We have to establish this carrot and stick, or we can say reward and punishment balance with technology in Turkey and Europe. The Espigaladores example from Spain is the dance of agricultural engineering with social innovation. Gleaning, collecting products left into the field after harvest, is a tradition thousands of years old. But Espigaladores turned this into an industrial model. The problem is this: markets don't want cracked carrots or small potatoes. These are flawless in terms of food safety, just cosmetically defective. Especuladores collect this product, but the real genius is here. Fresh produce has a short shelf life. Logistics are hard. They take 5% of the collected produce and transform it into jams, sauces, or purees under their own brands as I'm perfect. As a food engineer, I take my hat off to this. Why? Because by lowering the water activity of the product and applying heat treatment, they extend the shelf life from 2 days to 2 years. This way, they both rescue the food and finance the operation with the revenue generated. They also employ disadvantaged groups in the production facility. So, 3 birds with 1 stone: food rescue, shelf life extension, social employment. This is the circular economy. Now let's enter to software world with Phoenix from France and FoodCloud from Ireland are the giants of digital matching in food rescue. These platforms use B2B matching algorithms that solve the communication disconnect between supply and demand. In the past, a store manager would call charity one by one for the 50 sandwiches left on hand. Often, no one would answer or say, "We have no vehicle." The sandwiches would go to the trash. FoodCloud works integrated into the handheld terminal device in the store employee's hand. The employee scans the barcode, presses the donate button, and the system automatically sends a notification to the nearest charity based on geolocation and capacity. There are 50 sandwiches at Tesco. You have 1 hour. Phoenix uses a hybrid model. It first tries to sell the product to the consumer at a discount. If it doesn't sell, it directs it to donation. Also, the system automatically generates the donation receipt and tax deduction documents, which are the biggest bureaucratic burden. This platform have turned food rescue from a charity work into an efficient data management business. Another case study, my personal favorite, this is Central Kitchen, founded by Robert Edger. This model uses food not just to fill stomachs, but as a tool to change people's lives. Their concept is community kitchens. The engineering success here is menu engineering. Imagine as a restaurant chef, you know what you will cook every day because you ordered the ingredients. But random donation come to the DC Central Kitchen every day. For example, 500 kilos of broccoli today, 200 kilos of chicken tomorrow. They can taking this heterogeneous impulse and turning them into 5,000 portions of standardized meals with balanced nutritional value is a serious production planning skill. More importantly, who work in this kitchen? Former convicts recently released from prison or those with a story of homelessness. They give them certificate culinary training. These people learn not only how to cook, but also hasip rules and how to use knives. And upon graduation, they found job in luxury restaurants. So this central kitchen doesn't just upcycle food. It reintroduces people into the society. Let's look at two structures from our country that we are proud of. TIDAR is a Basic Needs Association, transformed the concept of social aid into social retailing. In the support market model, they establish a standard box is not given to those in need. They are defined a card and point limit. They enter the market and choose their needs from the shelves just like a normal customer. We call this freedom of choice, and it is critical for human dignity. In the background of is a technology startup, Fazla. Fazla is a platform that handles waste management. They install a smart scale system in markets, measure waste instantly, and decide with AI. Can this product be sold? Should it be donated? Should it become animal feed or biogas? This integrated structure has created an ecosystem that carries Turkey's food rescue capacity above EU standards. Time to go to the field. If you ever need to set up a food recovery center, here is the technical checklist you need to pay attention to. The first place you look is the floor. It is epoxy. It is washable. Are there drainage channels? Food safety starts from the floor. Second critical point, decision tree. It must be hung of the entrance of the warehouse where every volunteer can see it. What will the volunteer do when they pick up a can? And one is the packaging damage. If yes, dispose. If no, continue. 2, is there bulging? If yes, dispose. If no, continue. 3, has the best before date passed? If yes, is the product intact? You accept. These algorithms cannot be left to staff initiative. They must be standardized. And finally, legal documents. In Turkey, you cannot benefit from tax advantage without a capacity report. You need to call an expert from the Chamber of Commerce or Industry and register the capacity of your warehouse, shelves, and cold room. The bureaucracy of this business is as important as its logistics. Wrapping up our presentation, let's look at the future, the strategic roadmap. Food recovery activity is no longer a kindness movement, it's a complex system engineering problem. What awaits us in the future? IoT and sensors. Thanks to sensors measuring product freshness at the molecular level, we will talk about real freshness instead of expiration dates. 2, we can talk about dynamic pricing, electronic shelves labels which automatically lower the price as the product date approaches. And hyper-localization, food will be consumed and rescued at the point closest to where it's produced. Dear participants, our duty as food engineers and industry professionals is to reintroduce existing waste into the system in the safest, most legal, and most human way possible. Remember, every kilogram of food we rescue is not just a meal. It's also saved water, energy, labor, and carbon emissions. Thank you for listening.